record. Start recording. Testing. 1 Bitcoin, 2 Bitcoins, 3 Bitcoins. Homepage, course document. Bill content assessment, bill content homepage. Announcement. Hit announcement. V2, S1. All right, let's go. Welcome, everybody. Welcome to week number 2 of our favorite course. Alexa, stop. Right. How is it going? Questions? Okay, first question, then I have questions for you. First question, it is a poll. You here? Wonderful, great, wonderful, okay. Okay, get a hang of Miro. Uy, pam, pam. Okay, TCO 2021, here we are. Right, great, excellent. So I'm checking Miro board now, and I'm checking Slack. Okay, shall we continue with the slides where we left off the other day? Okay, good. Great. Slides. Animation. Great. I'm coming to you. Share content. Share application. Share window. Share Microsoft. Not showing because I'm on a Mac. Damn. Entire screen. I have to show the entire screen. All right, let's go to it. Any questions so far? No questions. Do we need the notes? No. No questions. Okay, let's go. We stopped here. We saw the difference between data information and knowledge and wisdom. We saw a few charts, examples. We saw how professional magazines make charts. And we were working in the Kaggle survey data, yes? And we were talking about this, and this. Yes, we saw the ISO measure, which is this one. And we also talk about arrows, including narratives and credits. I think we stop here. Yes, correct? Are you with me? Great. Okay, now.
We are with you, Victor. We are with you. Can you hear me?
You are with me. Great. Are you excited?
Yes.
Okay, now, challenge for you. Now, look at this chart. What do you think about this chart? Who's talking? Somebody's talking? Who was talking? Mariam? Asma?
Yeah, I think Mariam.
Hello, Arwa, Mariam. Okay. Any of you two, Mariam and Arwa, can you tell me what's wrong with this chart? Or anybody, bonus point.
I think it's information.
Yes, it's information. Good.
Bonus for me.
Well, why? You have to say why if you want the bonus.
There is data that we could have represented as information about the number of respondents and per age group, but we don't know for what or the purpose. So it's not knowledge.
Very good, because we don't know where to use it or how to use it, right? It's not even ordered,
Yes.
I would say. Is it ordered, this data?
No, not ordered.
No,
I mean,
because
No.
what about the numbers? We don't know number of response. Response of what?
okay, well, this is the data survey from Kaggle.
Okay.
So it's what? How much was it? 23,000
We
people.
don't know what's
survey, right?
gender, what's
Yeah, the gender itself.
You know, you only know this. I know. You only know this. 23,000 people, 4,000 are women. And this is the gender no, the age distribution. And we got this chart. This is the default chart if you use pandas on Python. How do you like it? Not very good, right?
Yeah, not very.
You have the number of respondents here. So the first thing we have to do when somebody asks you about a chart or when you explain a chart, the first thing you need to do is to explain the y-axis if you want to look professional, and the x-axis, just that, okay? Because people don't know what you're talking about. And so the first thing, okay, what is y? So y is people, data scientists, yeah? And x is age brackets, right? So is this data, is information knowledge? Definitely not knowledge. I wouldn't even say information because it's not ordered, right? So here we have 1821. So the younger people is here. And yes, we know which is the most popular bracket, right? But okay, this has 3 years age gap, and here there's 4. It's not
Years, yes.
apples to apples, right?
And
Not even
here-
apples to apples. And look at
Yes.
this, 10. Right, so if you want to know which one is the most popular and which one is the least popular, order it, yeah, but doesn't look very useful. It's pretty, yes. Useful, not so much. Sounds good? I would even remove this because this is not very useful. Right, so definitely not knowledge. Information, I'm not sure. Data, this is just data to me. Yeah. How do we call this chart, by the way? Do you know the name?
isn't it bar chart?
It's a bar chart, but it has a special name because it's called histogram. Histogram.
Oh yeah, and statistics, histograms.
It's a bar chart, but if you want to look good in my class, you want an A, histogram. This is a histogram. It's a historic, the name histogram comes for historical reasons. So it's a historic of the values that are more common. It's not a very good name now, but it has stuck. Okay, so we call it histogram, hist. Right, good. Now, challenge for you, I give you 2 minutes on Miro board. Sketch, how would you change this chart so it becomes more useful? Sounds good? You got this? Right, so let's go to Miro. I'm gonna
Yes.
pass this so you can see it on Miro. And I'm gonna make space here and pick up a square downstairs and try to make your own. Let's zoom in a bit. So pick up a square and try to make your own interpretation of this. How will you change it? 2 minutes. Let's go. 1, 2, 3. Do you want music? Yes. Okay.
Doctor, can you resend the link? I don't know why. Yeah.
Absolutely. For some reason, I didn't send it enough time. Did you get an email explaining all the links and everything? I guess no.
An email?
Ursula.
I don't think so.
No, we
Okay,
don't.
well, I will send you an email. Thank you for the reminder. I will post this on Slack as well. You can search for it. It's working. Here again. Okay. Stop timer. Let's reset now. Well, no, we need to put some annoying music. So let's go. Right, just sketch and do an approximation, or you can use Excel at home and do a quick bar chart of how would you arrange it, and then copy paste the image here. But you have lots of tools here to do a chart, like you can build it. You can build it by yourself. Sketch, it doesn't need to be accurate. All right. 1 minute 30. Okay, let's see what we got. Nice. Nice, isn't it? Look. Well, let's see again. 1, 2, 3. Right, time's up. Solutions. Anybody has something to show? Someone? No? Yes? Anybody? Okay, let's go back to the slides. Here. Sorry, here. Okay, so here's one solution. Same data and different ordering. Yeah, so same data, and now what's the difference here? Anybody? What's the difference between this one and this one? Yes.
So we have in the y-axis, see the
Yes.
numbers? He changed them. He
Yes.
make it like 2000, 4000 instead of all the numbers from 1 to 6 or 1 to
Very good. How do we call that?
y-axis.
Very. I have a listen. Yeah. Decluttering. We have decluttered the y-axis, correct?
Yes.
Do you really need to know that 5,000? So much precision? Maybe not, right? 3 is enough. Yes. Very good. So that's decluttering, and this is the same as we saw the other day with the chart, this chart, right? You cannot have information, you cannot have meaning if you have too much information. And this is a clear example where there's basically an overload of data here. Do you really need to know that 1000 is here? Maybe not. Right? So yeah, very good point. So we have decluttered the y-axis. What else? What's the difference?
We gave colors for the age groups.
I know the colors are so beautiful, isn't it? I love colors.
Yes, also we have an x-axis. If you see the numbers, it's become more clear. If you see, especially in
Yeah,
8 and above.
we make them bigger and filter them. Yes. What else happened here? Colors.
We added labels.
Labels. What do you mean?
For the x-axis.
Yeah, labels, tilted labels. Yes, that's good. Okay, so colors, very nice, right? Colors are nice. Now we see clearly that, what do we see?
Also, then see in an x-axis, he arranged them like 18 and 21. It's 3, both of them. Like this group we have 3, and this group have 4, and so on. If you know what I mean.
3 here is 2. Yeah. 1, 2. Well, 4 years considered here, and then 3 years here, and then 4 years.
Yes, I'm bad at math. Okay, I'm sorry. Okay.
No, it's true, it's true. This is an anomaly here. Only 3 years. Here 4, 5 here, yes? So here 25, 26, 27, 28, 29. 5 years considered here, right? And here only 3, and here only 4. So a bit of anomaly. This, I think this comes from the data survey itself, so there's nothing we can do about it. But anyway, now we see clearly the shape of the age curve, right? Very interesting. Now it's more interesting because it's ordered, and this is closer to information, mostly because we have decluttered and we have organized. So the key now to transform data into information is organizing, decluttering. Sounds good? And we start seeing interesting stuff, like data scientists are young people, right? Or the survey respondents tend to be young, and there's no old people, right? Not so many old people, right? Who are these people? Right? It's interesting. Good. Now, can we improve this? How would you improve this? How do we convert this into knowledge? Is this knowledge already?
No, it isn't knowledge.
It isn't knowledge so much, yeah. We need to go a step further, and here's one possibility. Now take a look. So this is the same chart, but okay, what's the difference here?
They decided to make the spotlight on Gen X. So from 45 till 54.
Yeah, that is true. We added some knowledge here that we discovered from this. We further decluttered whoever did this chart, yeah. Reduced.
And we specified the generations.
Right, so this is very interesting because it's another technique to declutter and create meaning at the same time. Are you familiar with the generations? Millennials, this and that.
So Gen Y is millennials.
Yes, and we are Gen Z, or HR.
And who am I? Who am I? Who am I?
Maybe more.
Why? Huh?
Excuse me? Excuse me.
You are with us, Gen Z.
Ah, okay. Bonus point for you. Right. So what is it? Yeah. So whoever made this chart and decided to get rid of the color, right? And declutter the ages, because ages don't have a lot of meaning. But if you start talking about Gen Z, Gen Y, then you can forget about the age and further declutter the whole thing, right? So I'm trying to hide this, but you can hide the ages and just put Gen Z, Gen Y, and then when you apply these labels to the age, you create meaning. Ah, these guys are Gen Z. Ah, Gen Millennials. Yeah.
I think he could have decluttered further by simplifying where does Gen Y start and where does it end.
Absolutely.
Instead of having two different years.
Yep, absolutely. So we could have a few bars only for Gen Z, Gen Y. 4 bars only. Yeah. But anyway, what is the knowledge that was created here?
The top grossing cohort is Gen X.
Yeah, even though they're not the highest numbers of people, right? So it means people from 45 to 54 top grossing. So this data is about a website called Kaggle, and Kaggle is like the Olympics of data science. And what they do is they organize competitions. So the guy who made this chart, who's probably Gen X, right? So wanted to check who knows more, who wins more prizes, no? Who knows more, the young people or the old people, right? And he decided to check by age who wins more prizes. And he found out that if you divide by the number of people in each cohort, a person from Gen X is the most likely to have won some competition. Yes? Normalizing by person. So the probability that you pick one guy from here or girl from here or from here. So if it's a Gen X, the person is a Gen X, it has the highest probability of having won some competition, which means if you want to hire a data scientist, the most knowledgeable age is this one, right? Even though young people are so good, but yeah, sounds good. Interesting. So from here, data, information, knowledge. How good. And focus, how did they create knowledge here? They just didn't stay with their own data. They connected this data to other bodies of knowledge. In this case, who wins money, right? And that is how you create data, knowledge. Sounds good?
Yes. Yes.
That doesn't mean that every time you have a chart, you have to go out of your way and do something else. But if you have a meaningful job, or if you want a meaningful job, or if you want to have an impact in your organization, when your boss says, hey, make a chart of this data, if you want to go the extra mile, try to create knowledge. This is a very good example. I did this chart, and it was so popular that Google, they came back and they gave me $3,000.
Wow.
So, yeah.
$1,000. It's good. It's very good.
Yes. And by the way, do you know how I made this chart?
By one of our softwares that you're gonna teach us?
No. Look at the space. Look at the space. Look at the space between these two bars and this one. Do you think it's the same space?
Yes, they are the same. But
no,
not
this one is.
No, they are not the same space.
I made it using PowerPoint. I just copy pasted this, chart, I made it shorter. I changed and I replaced each bar by a square, a triangle, a rectangle. Yes, and then I typed this by hand because it was faster than program Excel to do the colors I want. Sounds good? And the same for this. This is Arial type font from Microsoft PowerPoint. Yes? Good. Next one. You can find the code here. Like to find this, by the way, it took a lot of work actually. So let's see if I can.
Really?
Oh, yeah. Like the problem with creating knowledge is that it takes a long time. That's why, well, it's not for the lazy people. So this is the story I posted. This is a notebook, and this is how I won $3,000. So to find out this, we estimates. First, I made a separate survey by myself. Here you have. You still can take it. And then we did some code. So I looked at the winners, and then I asked them, send an email, ask the age of the winners. So making knowledge takes time. Yeah, it's not that deep. But this PowerPoint, not Excel. Sounds good? Wonderful. Let's go back to it. Next one. Another challenge for you. Okay, this is another data from this survey from 2018. And I took this chart from a user called Head or Tails in Kaggle. And so you can find this chart in his code. And what is this? Can somebody tell me what is this? What is this? What is this?
What is what?
What is this chart about?
Yearly salary.
Okay, so
and these are responded.
Yeah, can you tell me what type of chart is this?
Histogram.
Instagram?
Histogram.
Histogram. Right. So y-axis is people, respondents, and here we have what?
How much money they make per year.
The salary brackets. Very good. Dollars. Very good. So what do we see?
On y-axis, the year. Oh, this is the
No.
Year. No, this is the respondent. Yes, I'm sorry.
So here to make the confusion less, we could draw people, no? We could draw a human here, right? Is this like a data scientist, okay? And then you don't have to think so much what is what, right? Humans here, right? Right, so, well, how would you create more meaning out of this chart?
To add more information, like what is the ages spent on the salary or their experience in years.
Okay, that could be a good idea, yeah, to
and
further... Go on.
And to reduce the label from, instead of adding 3 zeros, we can just write K.
Absolutely, this is totally crazy, yes. Very good, what else?
I also changed the y-axis instead of from 0 to like 1, 2, 3, 4. I will make it like 2,000 and 4,000. That's it.
Very good, and that's decluttering. And that's decluttering, and it helps us to go from data to information, but the difficult part to go from information to knowledge.
Yeah. I mean, it depends on what do you want to know from the chart.
And that is the problem, right? We don't know what we want to know, right?
How come they don't specify?
Well, imagine your boss gives you this chart and says, Arwa, you know, make a report that is meaningful and is interesting, right? How do you go the extra mile to create knowledge out of the data? It's not only about making the chart beautiful and easy to read, right? It's about how do you connect this data to other data so that it becomes really interesting, really useful. Let's see an
Okay, but
example
what does
here.
he want to
Yeah.
know? Capitalism?
That is the problem. You don't know what you don't know, right?
Yeah,
We don't know what we don't know. And so the way to solve this is to explore the data as much as you can. So, for example, so now don't be scared, okay? Because we're going to check.
But want it to be biased, the article, based on what the person's own point of view?
Anything that is knowledge would be good. Like, look, can you see the screen?
Yeah.
This is the exploratory data analysis. This is like when you don't know what you want to explain or how the data looks like, you do an exploratory data analysis. And this is the exploratory data analysis by Head or Tails. As you can see, I took the charts from him, yes. So he explored the data in many angles, many angles, by country, by degree, by college, by subject, by job and industry. This is the salary, by so many things, right? Like this goes and on. He also got an award, I think. And this is the code, how he did these visualizations, right? Now let's go back to here. So, for example, let's say your boss is interested in equality issues or poor people versus digital people, or if you took my ethics class, the digital divide, for example. So another way to show this data would be something like this. Like, since you're talking about salaries, right? You have the rich people, look at these people, $500,000 per year, not so many. And then you have poor people here, right? So
The
another
top
way to show this,
1%.
the 1%. These guys are the 1%, right? So you could talk about the 1%. You could connect this data to the 1%. Now you're thinking, and you could say, wow, are data scientists part of the 1%? Privileged people or not privileged? Or are they the same as the rest of the society? So that could be a very interesting idea to explore, right? And actually, it is a very good idea to explore. But to explore it, a better way to show the data is to rotate the chart 90 degrees, like here. The same chart rotated, you see that? And now what do you have? You have the rich people at the top, yeah, and the poor people at the bottom. And this looks like a pyramid, maybe? Are you familiar with this one? And then you can quickly use the pyramid metaphor to build your chart. So same data, it's the shape of it, the money, and then the length becomes the amount of people in each salary bracket. Now here becomes very interesting because you have this metaphor of the pyramid, power at the top, less powerful and more abundant at the bottom. It's very easy to understand. It fits the pyramid metaphor, and then the chart becomes self-explanatory. And then you can talk about inclusion and income in data science, and you can start talk about the 1%. And so if you know that or you can look it up and you can say, well, in the USA, to belong to the 1%, you must earn $422,000 per year. And here you have, maybe, is this 1% of the whole thing? It looks like more or less like the 1%. So you can say, yeah, data scientists, yeah, 1%, similar statistics as the rest of the population. To belong to the top 10%, you need to earn 172,000, right? And if you make the numbers, you see that 6% of data scientists belong to the top 10%. What does that mean? That means that data scientists are slightly richer than the general population, or earn slightly more money than the general population. Yes. And you can go global, and don't think about the US because this survey is global, and you can point what is the salary level to become global 1%. And so to be part of the 1% in a global scale, you only need to earn $32,000 per year if you include China and India, right? And here you can see that, wow, like 60-70% of the data scientists belong to the 1% because they are above, right, of the level of 32,000. And so that means that in general, data scientists, it's a privileged class, if you want to talk about that, right? And yeah, it makes sense, right? Because to be a data scientist, you need access to a computer, and that means, so that links with the digital divide, right? So that means that you are already rich if you can study data science. Makes sense? So is this data, information, or knowledge? Well, we have gone from data or information, really useful knowledge by doing what? By introducing or comparing our data to the concept of another data called the 1%, right? So 1% in the US, 10% in the US, and 1% global. Make sense? And what else did the author do here? He added emojis, right? So indicating that when the data scientist salary is similar to the society salary, that is good because it means it's not an elite group. And when it's not, then it puts this emoji to indicate, hey, this is not so good. Sounds good?
But isn't it not professional?
Which part is not professional?
Adding emojis.
Oh, right. So there's a lot of research on that. So the older the person reading it, the more likely it will not find it professional. True. Yes. But the younger the person is, the more likely it will find it good. Yeah. So it's a trade-off between communication effectiveness and being professional, or being judged as professional by old people. Sounds good?
But doctor, to be honest, if it's like local, someone in here local, it will say this is not a professional. Just do it again.
That's fine, and you need to understand which is your audience.
So
Yeah,
yeah,
I think the people in Kaggle found it very professional because they gave me $3,000. So
Yeah.
yeah.
But I wouldn't worry too much about emojis. Like the the value here is understanding to change the axis. Yeah, so always think about, can I change the axis to make it look better?
Changing axis?
Flipping the axis. Yes. We flip the
I
axis.
think, yeah, it looks better.
It looks better because you can apply the gravity metaphor where rich people are at the top and bottom, whereas here, and metaphor of the pyramid and apply to the chart, and then it becomes very easy to understand. Next one. This one is, okay, what is the problem with this chart? Can you tell me? Or first, what is this chart?
It's too detailed.
Too detailed, yeah. What is the y-axis?
Country of residence.
Of the data scientist, yeah. So which one is number one?
US?
USA.
Very good, yeah. And what kind of chart is this one?
Country of residence?
Instagram.
Instagram, yes.
It's an Instagram chart.
Histogram. Histogram.
Yeah, that's what I said. Histogram. Oh, thank you for correcting me. Good. How can we improve this chart?
Generalize the countries. Like
Very good.
into, what are they called?
Continent.
Continents, yes.
Continents. That's good, but you have continents where you have
To
rich
generalize.
countries, poor countries together, right? So here's another way. And again, they flip the axis here and they use not continents, but economic areas. So they divided the countries by economic areas. US as one area, European Union as another area, and what we call BRICS, which is Russia, India, China, Brazil. Yeah, these four countries, even though they are in different continents, they are very similar because they're growing at the same speed and they are more or less the same richness level. Sounds good? And so you have countries that are economically quite similar in GDP per capita and in GDP growth. And then you have European Union, which another group of countries quite similar, and then the US, and then the rest. So they decided to simplify, making this mess of 256 countries into 4 countries. And then what do you see here? So you see the growth. So they didn't stop here. They look at the previous year survey and they look at the change in each mega region. They look at the change, contribution of new data scientists from 2017 to 2018, the growth. So what you can see is the typical story, like wealthy nations are big, but that's not interesting to know that US is big. We already know that. But what's interesting is to know what's going to happen in a few years, right? So what you can see is that most of the new data scientists that are created are not in the US, not in Europe. They are from these 4 countries: Brazil, Russia, India, and China. And that is interesting, which means that in a few years, data scientists will be dominated by these countries because they are growing 4 times faster than the rest of the countries. Sounds good? Interesting. Wow. Yes. So again, the guy who did this didn't stop at the boss told me to make a chart. He said, okay, to know what's happened in 2018 is interesting, but what's interesting to know is how things are going to change. So it took the difference in growth, and then make the mega regions. Sounds good? Did you know this concept of BRICS? So BRICS is another concept.
No, first time I heard of it.
Okay,
Yes.
super famous in finance. It was invented in 1996 by Goldman Sachs. But they had this problem that they had too many countries and they want to talk about the fast growing companies. So they said BRICS, and it's stuck. And it's another example. How do you create knowledge? I have this data, but I know that this is not interesting. What's interesting is the change. And then I need to simplify these countries. Countries is always a problem. Continents is a good choice, but economic mega regions is a better choice because there's more consistency and the countries look more similar. Whereas if you put Africa in one as a continent, you have South Africa that is completely different from the rest of Africa, and you have Tunisia, Morocco, very different from Central Africa in terms of science, data science, everything. Doesn't make sense to put them together. Fantastic. Another solution. This is one solution, but there's another solution. And the other way to look at this is connected to another framework. And this framework is called the density framework. And the density framework is to look not at the size of the countries, because of course, in any chart like this, USA and India and China are always the top three, isn't it? And what is UAU? I don't see it. What is it? Because we look at absolute numbers, but absolute numbers are not very interesting, especially when you talk about countries. What's interesting is per capita. Yes? And if you look at per capita, like the number of people that reply for every 10,000 people, then you have Singapore, number one. Singapore, there's so many data scientists per 10,000 people. And then you can rank countries like this. Yes. And then here you have the European Union, and here you have BRICS. And this is very interesting because then you can have another chart where you plot the density of data scientists for each country. Yes. And you can plot here another dimension with the Global Innovation Index. And then you can see how the countries spread in this scatter plot. Sounds good? So you can see, for example, Switzerland is very high in innovation and number 3 in data scientists. Wow. And Nigeria is very low in both, and so on. Once you have this kind of chart, you can always do this called regression line, like this, right? And this regression line, you can apply this principle called mean reversion. It means that if you wait 10, 20, 30 years, all the countries, if you have a country here, there is like an invisible force that will push the country towards where are the other countries, right? So that's what we think. So for example, look at the case of Japan, right? If you apply this principle, where do you think Japan is gonna go in 10 years in this chart? You think it's gonna go up, down, left, or right?
I think it will stay as it is. This is for innovation, right?
Mm-hmm. Here we have innovation index. It's an index
Yeah.
that ranks the country by innovation. And here you have density of data scientists, right? So look at Japan. What do you think about Japan?
I think right and up, but not
Japan
much in the population.
Okay. of data scientists. So Japan is a
Yeah.
very interesting case, right? It's very high on innovation,
So it's gone
but
up, right?
but it's worse than almost everybody else in data scientist density. Yeah, it means they're not very good at data science. Sound good?
Really?
Yeah, well, that's what the data says. They don't have a lot of people working on data scientists, if you look at the chart.
But I
Yeah.
think it's mostly because of the population.
What do you mean?
Like I don't think there is a huge population of Japanese people in general.
Well, there's 123 million Japanese, but here is number of data scientists per 10,000 population. So we don't care about the population anymore because we have density here.
Oh, okay.
Right? So Japan, very high in innovation, very low on density of data scientists. Yes? So that means if you have a Singaporean company, for every 10,000 people you meet in a company or in the street, 0.3 will be data scientists. But if you're in Japan, only 0.05 will be data scientists, 6 times less. It means that Singapore has 6 times more data scientists per company, per business, per person, per population than Japan. Yes. So maybe this is because Japan has been slow to adopt data science. Maybe just the survey, the way it was made. But it looks interesting. But if you apply the concept of mean reversion, you would think that the situation in Japan will improve, that the number of data scientists will slowly catch up with its peers, and that the innovation in Japan, which is one of the highest in the world, right, will also go back to normal. So if you apply this principle, you would say that Japan will move towards here in the chart. Sounds good? And then you can use this chart to forecast what will happen with a country, right? And so that makes it very interesting because from here, we have, by connecting this data, growth data, and the innovation, right? Are now that you can use to forecast or predict where each country might go in terms of data science and innovation. Sounds good?
Yes.
Is this data, information, or knowledge?
Information.
Okay, give me a second. I'm busy now. Yes, sorry. Data, information, or knowledge?
Knowledge.
Well, the moment you can use something to forecast and predict, that definitely is not information. That's more like knowledge to me, especially if you compare it to where you start from, which is this. This data is not very usable, not very useful. This one is more useful. Like, oh, who will be dominating data science in 20 years at this rate if nothing changed? These ones, these countries, not this one, which is number one now. In the future, number one will be this one. Interesting. And what's going to happen with the number of data scientists in Japan in the following years? Will it increase or decrease? It will probably increase. Will it go to the level of Turkey, Mexico, or Nigeria? I don't think so. It will just grow if you apply this principle, which by the way is quite true all the time. Interesting. So that is knowledge. So look how you have taken data, and by connecting to the right external knowledge, you have created, or you have made your data useful to somebody. Yeah. And also look at the visualization here. We could declutter even further. We didn't put lines here. Yes. So that all helps to make it more useful. Good, excellent. So that's a very complex example. So knowledge for sure. Right, awesome. So how would you visualize the last 20 slides? Bang, challenge. Let's go to Miro. I'll give you 5 minutes.
All of them?
All of them, and I guess here we don't want data, we don't want information, we want wisdom, right? And wisdom means, okay, what are the 3 things that I learned in these slides? If I have to summarize it, you can write it as a text. You don't need to make a chart.
It's not about the charts that we saw. We just need to synthesize
exactly.
what we learned.
What did you learn? Like, what did you really, really learn that you can apply anywhere? Wisdom, yes?
Okay.
Two minutes left.
Bang. Okay. Wonderful. Mariam, you're so funny. Bonus point for you. No, actually more, more, more into, I'm more into millennial, on the edge of millennials towards Gen X. Right, thank you. Okay, who wants to go first? Yes, this one. Who are you?
Me.
Yeah. Okay, do you want to explain your summary?
Should I explain them all?
No, but what's the main takeaway?
These are the main takeaways.
Very good. Okay, yeah, I agree with them, all of them. Yeah.
Yeah.
The point of the chart is the narrative, remember? And the problem is that many people make charts and they don't know what they want to say. And that's why the chart looks like, so what is the chart for? Why do you make this chart, right? So many people make charts, but they don't know what they want to say to you. They don't have a clear narrative. Sometimes a chart doesn't have narrative. It's just to explore the data. That's fine. Like we saw, head or tails, no? The mega Kaggle master. He make 1,000 charts. He need to explore the data. When you do a presentation, you don't do this unless the point is to explore the data. But when you want to convince people or to say a message, then you need to think, okay, what do I want to say, right? And so that's another important point. Many charts feel like noise because they don't have a narrative. You do a chart, and when you want to convince people, you need to think, okay, what do I want to say? Today's lesson, pie charts called histogram. No, bar charts are called histograms when they are histograms. Not all bar charts are histograms. Here you have a very good definition of history of histograms. It's only like 100 years old, 200 years old histogram. Yeah? And you will find the reason why it's called histogram. The reason is that you will find out. The other one, to turn data into knowledge, we need to connect it to other knowledge. Perfect. That's very good. Yeah, what's the difference between this, how to do that? Yes, and how to compare charts. Yeah, and how to improve charts. Yes, and this is the summary that you know. This pyramid, it's called the data, information, knowledge, wisdom model. And here you have how to jump from one level to another. So one way summarizing, yeah, from here to here. From here to here, connecting, and from here to here that you will see at the end of the course is storytelling. Storytelling is a job. There's people that get paid to tell other people how to explain something. So they are unbelievable. There are storytelling consultants. Can you believe it? There's a job, and your job is to explain to other people how they should tell a story. and it's on for business. One of the most famous consulting companies in the world for storytelling is woman, Nancy Duarte. Her job is to make PowerPoints for companies, and she gets paid $1 million per PowerPoint. Can you believe it?
Wow.
Yeah,
Oh, 1
she
million
advises.
Can we see her
she advi-
PowerPoint?
Come again?
Can we see one of her PowerPoint?
Yes, because they are
Yeah, we
famous.
just want to get inspired.
Yeah,
Yes,
but you have to get money for
she
PowerPoint.
has Nancy Duarte. She has a very good TED talk about her life. She had a very hard life. She has two very good PowerPoints, or sorry, explanations. One is this one. The secret structure of great talks, and it's fantastic. I think we will watch it as an assignment one of these days.
Right away. An idea is
Really fascinating, really incredible woman. So she's one of the most famous storyteller consulting companies. Right, so this is all for today. I'm gonna leave this link here, and of course, if you have time, watch it because it's beautiful. Questions?
No, doctor. Doctor, you gave the presenter to the wrong Mariam. Just to
Come
make-
again?
I mean, you gave the presenter to the wrong Mariam. I mean, just to make sure to know
Oh,
future.
It's okay.
It's
Good.
just to make sure for the future.
Don't save. Good to know. Good to know. Right. So we covered chapter 1 of the book, chapter 1 and 2, I think. So you can, if you want to go deeper, you can read chapter 1 and 2 and do the exercises inside. But this is it, more or less, what you need to know about the difference between data informational knowledge, the data information knowledge wisdom model, and a few examples of how to transform. And if you're good at this, then, well, you will have a lot of job offers. Sounds good? Wonderful. Okay, good. Okay, so I'll see you in a couple of days. Yeah, if there are no more questions, I will send an email with all the instructions to links and stuff like that, and I will send a small little homework, nothing important, for the weekend. All right, I'll see you next day. Oh, attendance, hold on. Where is it? Services. And okay. Right, good. Okay, everybody's here. Yes, 9 people here. Okay, done. Bang! Have a good day, students.
Thank you, you too.
All right,
You too,
visualize
doctor.
something cool. Ciao, ciao.